we want to look at the robot instructions. You will get a lot of problems, well, I don't know about a lot, but you will definitely see a variety of problems that involve a robot in the form of a little triangle on a grid. And the robot will have some instructions to follow. And you might have to say where the robot will end up if it follows those instructions. You might have to say, you know, whether or not the robot would even be able to follow those instructions. But this is how you would see those instructions. The command to move forward, which, you know, over here it tells you that the robot would move 1 square forward in whatever direction it's facing. The way that you would see that would be this rounded rectangle and the command move forward, all caps, and it would have this little underscore. And that just means that that is the command to move forward. Rotate left, you would see like this, rotate right, and again, just remember those are in place. It doesn't actually move horizontally or vertically, it just rotates in place. So we would have rotate left, we would have rotate right. Now right here, we were just talking about Booleans a second ago, and that was just kind of a side note, but right here, that's where this comes into importance. So the robot does have a Boolean associated with it, and you might see something like this on the exam. So the block might say something like this right here. So can move in whatever direction. And that direction might say right, might say left, might say forward. So can move in a direction. Over here, it tells us that this would actually evaluate to a true or a false. All right, and we've talked about that before. And if it is true, then probably there will be some other instructions telling, okay, well, if you can move right, then do it, move right. But if you can't move right, maybe there would be a different instruction on what to do instead, such as rotate. So those are some things. And if you remember the term for that, these are Booleans. These are true and false. In Scratch, these are hexagons that tell us whether something is true or false. And you can click on the hexagon in Scratch to find out. These you would have to figure out yourself based on the robot's position in the grid. So that's just a quick tour through the reference sheet. We didn't cover everything. We definitely will look at all of these before the exam, but it's just to get started thinking about how you might see Scratch that you're learning in this visual way with blocks and all of this stuff, how you might see that on paper, because the AP exam, of course, is paper and pencil. So you've had a look at the College Board's reference guide, and all of the things that they have in there are very, very general. There's nothing really specific in there. They use A and B for all their variables and expression for, certain things. So let's take a look at some more specific ways that you might actually see this stuff on the exam. So what we're looking at here would be an example of the first section that we looked at, the assignment, display, and input. And so you can see a few of the things that we looked at. We looked at this display instruction. Hopefully you recognize this as an assignment where we have a variable called user password, and we are assigning it a value that is coming from user input. Okay, so it's not expression now, the expression is input. And we're going to repeat until some missing statement is true. And so it's going to display invalid. Try again. Notice the quotation marks. This is a text string that is being displayed. And it will then, again, it'll keep repeating this, set the user password to input, which means that the user is trying again, like try again, that wasn't right. All right, so right there. So this is the exact same thing, but we're hoping that the input itself is different. All right, so over here on the right-hand side, we see how this might be implemented in Scratch. And you can see that there are very many similarities from the Scratch to the AP style pseudocode. All right, so when we want to get user input, like right here, of course we know that that is going to end up being an ask and answer situation. So we want to ask, what is the password, and wait. And look at this right here. These are exactly the same. Scratch is just a lot more colorful and pretty, but look at that. Set user password, that's obviously a variable that we've created in Scratch, to answer. Well, answer is the user input. So those two are very closely related. Then we have our repeat loop. We haven't talked too much about that yet, but we're going to. We will definitely talk about repeating or iteration. We are going to display, the way we display in Scratch is we use the say. All right, so say invalid, try again. We know that that is going to display as the cat with a speech bubble with the words invalid, try again in the bubble. And it's going to say that for 2 seconds. Now, that part isn't necessarily something that you would see in AP style pseudocode. You wouldn't see the duration of the display, but we know that for Scratch we have to have it. And so then we have to prompt the user for more input because we're assuming that the first time they tried it, it wasn't correct. So we prompt them again and again set the user password variable to whatever value they typed in as their answer, their input. So these are this is something that you would absolutely see on the exam, and this is how we accomplish almost exactly the same thing in Scratch. Let's take a look at another example. Let's take a look at an example from the arithmetic operators and numeric procedures. So this kind of combines some of the things. We already know that right here, this little line of pseudocode is an assignment. We are assigning variable y a value of 2. Okay, so we are setting y equal to 2. Oh, well look, right here. We've already done something like that. We've already done that in Scratch. We set y to 2, or whatever variable it was, to whatever value it was. All right, and it says then, repeat until some condition has been met, and these are the instructions to follow right here. Set y to, this is that expression that we talked about. We said the expression might be another letter, it might be an actual value, it might be a string, or it might be a mathematical expression. So y minus 5. All right, so basically what we want to do here is we start y off at 2, set it off to 2 to begin with, and then based on some condition being false, we're going to keep on subtracting 5 from y. All right, and that's right here. So repeat until some missing condition, there's that hexagon for a Boolean, and condition is Boolean. So repeat until whatever condition happens, decrease y by 5 throughout the loop until the loop stops. All right, and then we've got right over here, here's another example. This is an assignment. We've got a variable called turn, and whosever turn it is, we are setting it to whatever turn was last time plus 1. So if turn was 2 last time, now turn is going to be set to 3. When turn is 3, then turn will be set to 4. All right, so, and this is how we show that in Scratch. Remember, our operators are green. So operators like add, subtract, multiply, and divide are going to be green. And there we've put in the value, the variable turn, and turn plus 1. All right. If a certain condition, condition 1, so, on the test, they're not going to tell you what the condition is. You have to figure it out. So here's our empty hexagon, some condition, if some condition is true. Then display, and remember the way that we display in Scratch is with the say block. Say player 1's turn for 2 seconds. But if that's not the case, if this condition isn't true, then it must be player 2's turn. Okay, so hopefully that starts giving you some ideas about, how would I know if it's player 1's turn, who went first, took the first and the third and the fifth and the seventh turn, versus player 2's turn. So that, gives you just a little bit to think about on what that condition might be. But it just goes to show you that this is very, very similar in structure to Scratch. Okay, so last but not least, a robot example. So we have the set of commands, and we talked about how the commands that the robot can take are move forward, move backward, rotating left and right. So we have a section of pseudocode right here that says that a series of 4 commands is going to be repeated 4 times. You will not see our friend the Scratch Cat on the AP exam, sorry, but you can think about this in the context of Scratch pretty simply. This is an example of a grid that you might see. The grid will have some squares blacked out, and they will have a gray square showing you the target. All right, and so what you would do is take a look. Behind the cat is a triangle. okay? And you would be able to tell the way that the robot is pointing by the direction that the triangle is pointing. And in this particular case, the triangle was pointing in a downward direction. And we can imagine that that's our cat, and we can see that the cat is facing downward. And we know that the robot and the cat both move in the direction that they are pointing. So obviously the cat has been given a command previous to this to point down, but here's how we would implement this pseudocode in Scratch. So here's our same old repeat 4 times. We have move forward. It just so happens that in Scratch, I had to actually give a number of 48 to watch this and to see what would happen. So 48 pixels happens to be the right amount to get our cat to move exactly 1 square. So that's why the number 48 is in there. On the AP exam, you will not see a number. You will just assume that it moves 1 square. Then rotate left. Oh, look at that right here. We have rotated our sprite left plenty of times. All right, so turn left or turn counterclockwise 90 degrees, move 48 steps again, because now you're pointed in a new direction, and positive 48 is going to change, in the direction that you're facing 1 square, and then turn the other way 90 degrees counterclockwise. And that is exactly what we saw in the pseudocode. Forward, left, forward, right. And of course, it is assumed in the pseudocode that the rotation is 90 degrees. We had to actually supply that parameter in Scratch. But this would actually produce the cat moving to the target square. You will see pseudocode, of course, in the lessons for this course. You will see them on assessments, and of course, you will see them on the big day of the actual exam.